Alright, so now let's do our calculations for the critical limit. So just to abbreviate, we'll call critical limits CL. Remember that's mu, the value, the middle of the distribution, the hypothesized mean, average receipt, plus and minus the z value, 1.96 times the S of x bar, the estimated standard deviation of the particular sampling distribution, rounded to 4 significant places, 0.8655. So I'm going to go back to my calculator using the number that's already up there, the exact number multiplied by 1.96, and write that down. So it's 15 plus and minus, and round this off to 4 significant places. It's 1.6. Sorry, yeah, 1.696. Alright, that's 4 places. Forget the decimal place. That's 1, 2, 3, 4. The fifth number was a 3. It's below 5, so it stays as a 6. Alright, so now 15 minus 1.696 has too many places. So we'll round that off. That's 13.302 and add 1.696 to 15, and that'll be 16.70. Remember the 0 at the end of each of these numbers is a significant value, significant place. Alright, so let's start a new page. New screen. Since we're going to do that, I've got to redraw the distribution. The distribution of x bars, all possible x bars. That was a hypothesized distribution anyway. The mean of that distribution is 15. If you like, you can write down the standard deviation. S of x bar is 0.8655, if I remember correctly. And we have what are called critical limits, 13.30 and 16.70. In between the critical limits, there's a region in between. It's called the acceptance region. And on either side, in the tails, wherever the alpha is or parts of the alpha are, we'll call the rejection region. And the reason for those labels we'll see in just a little bit. Alright, so both sides where the alpha are is the rejection region. Alright, so now we have our calculations. That was the second part. The third part is the decision rule. We're going to base those on our calculations. Two parts. Part one, they correspond directly to the null hypothesis. If the null hypothesis is true, then we'll find sample averages between $13.3 and $16.7. Okay, so if x bar is between 13.3, 0 if you like, and 16.7, right now we'll say, and we'll change it up later to make it more accurate, we'll say we'll accept the null hypothesis as being true. And again, down the road we will put some verbal interpretation of what that means. Alternatively, well, the alternate corresponds to the alternate. If x bar is not between those two values, in other words, out the tails of the distribution, where the alpha is, not between 13.3 and 16.7, then we will, no quotes here, reject the null hypothesis. Alright, remember the two hypotheses. You don't like one, you gotta like the other one. So we'll reject the null, and in its place we'll accept the alternate as being true, more likely. Alright, and that's your decision rule. Alright, the fourth part, the decision. What we do is we get our bit of sample data, which was the, let's see if we can find it quickly. Sample average is 13.85. 13.85 is somewhere between 13.3 and 15. We'll place it here. It's the X bar. It's between the critical limits. Alright, and so we'll use part one of the decision rule. So, decision, since or as X bar is between 13.3 and 16.7, again in quotes for right now, we'll accept the null hypothesis as being likely. Other than the fact that later on down the road we will clean up this concept of accepting the null and put interpretations in, that's the basic hypothesis test. For right now, the decisions to accept the null corresponds nicely to the terminology of the acceptance region, and rejection the null corresponds again nicely to the rejection region. Alright, let's stop there and we'll look at another example in a little bit.